back. This is Techmath1. We're looking at the review for chapter 11 and 12, and this is part 3. So we're going on to the last 2 pages of the review. And so this one is the hardest problem on the review for sure. I don't know if you'll quite see one this tough on the test. So they want us to find this angle or side Z. It's not a 90-degree angle, so we can't use SOHCAHTOA. I erased SOHCAHTOA. That's right triangle trig. So what we're going to have to use here is either the law of sines or the law of cosines. So this one lends itself to the law of sines for the second part, for Z. The area is a real tough one, and I'll show you how we're going to do area. But first, let's find Z. So how does law of sines work? It's kind of basic. It's the side opposite, like this 20, over the sine of the angle opposite. So the side opposite over the sine of the angle that it's across from is equal to Z, the side opposite over the sine of the angle it's across from. That's the law of sines. And so now we just solve for Z. We don't really have to cross multiply and solve here. You can just multiply the top by sine 120 and the top by sine 120, and then those cancel. And so now you have this. You have 20 times the sine of 120. Make sure you put that parenthesis in there. I'm going to make it super dark right there. Before you can type it all in at once, that's fine, but you have to remember that parenthesis. Lots of students make this mistake. They go 20 sine, and then it puts a parenthesis down, and they put 120, and then they immediately hit divide, sine 47, and then it takes 120 and divides it by the sine of 47, and then takes the sine of that, and that's wrong. So you have to do this end parenthesis when you're typing it in, and then the divide by sine, and then that. Okay? So when you do that, you should get, what answer did I get for this one? Where am I? 21. 23.683. Okay, so apparently they want it to thousands place. All right, so we used the law of sines and we found the missing side. Great. Here's the problem. To find the area of this, I need 1/2 base times height. And they gave me the base as 20. So I already have that part. But I need the height. Well, to find the height, that's there. From a 90-degree angle to there. Well, I don't have that. That's not given. So what I'm going to have to do is I know this is a straight line, so that's 120, so this is 60. So I got that going for me. All right? I'm going to need to find this side, and then eventually I'll find the height of the triangle. So I need this side before I can go. And I can use my right triangle trig for this, SOHCAHTOA, because I dropped this the altitude, so that's 90 degrees. So that's going to be the hypotenuse. So if they gave me 2 angles, they really gave me all 3. I add those 2 up, 167, and subtract from 180. So 120 plus 47 is 167. You subtract from 180. That's 13 degrees. So I know that this is 13 degrees. Well, why would I do that? Well, because I need this side before I can work this triangle to find the height. This is what I need. This is a really hard problem. The area, anyway. This wasn't bad. Okay, so now I'm going to do the law of sines to find this. We already used that once. We'll use it again. 20 over the sine of 47 is equal to, we'll call that x. X over the sine of 13 degrees. Okay. Oh, I think in the worked out one, I called this h and this x. I'm just going to leave it how it is here, so just be aware of that. All right, so now let's find x. So we multiply both sides by the sine of 13. And that cancels, and then the sine of 13. Remember the end parenthesis on it, so you type that into your calculator, and that will kick out a 6.152. So small, 6.152, okay? So now let's pull this. We'll redraw this triangle over here. So that's 90. We know this is 6.152, and we know this is h. And we know this is 60 degrees. So which one? It's a 90-degree triangle because we put that 90-degree altitude on there. So opposite and hypotenuse is sine. So the sine of 60 degrees should equal h over 6.152. And then I cross multiply and solve. So 6.152 times the sine of 60 is equal to h. All right, and so you type that in, and we're still not done. That gives us the height of the triangle. So that is 5.328. And now we take that into this formula, okay? So 5.328 times 1/2 times 20, and that's 53.28, which is to 10th place 53.3. A really tough problem. We had to use the law of sines, find this side, draw this out, put in the height, use the fact that that's a straight line, so 120 minus 180 is 60. Use right triangle trig, sine of 60 is equal to the height over the hypotenuse. Solve for that, put it back into that equation, 1/2 base times height. This is the base, this is the height, and figured it out. Whew. So that is a really hard problem. There won't be anything quite that tough on the test, not where you have to find the area like that. All right. Okay, so let's continue on to this one, number 22. They said find y, side y, find angle z and angle y. And they gave us this figure. This is 15, and this is y, and this is 12, and this is x, and this is 35, and this is z, and this is y. Okay, so to find y, we're going to use law of sines. We've got, we got to find the angles first. They always do this where we have to find what they gave us first. So look, we have 12 over the sine of 35. And that will equal z, 15 rather, over the sine of z. Okay? And that will give us that angle. So let's find that angle first. So we cross multiply and solve. So we have 12 times the sine of z is equal to 15 times the sine of 35 degrees. Okay? And now we divide the 12 out. And we got the sine of z is equal to that mess. Let's see, did I work that mess out or did I do it all in one shot? No, I worked that mess out. So 0.71697. Again, when you entered in 5 times the sine of 35, make sure you put this end parenthesis and then divide it by 12. And you should get that. And now we do the arc sine of that. So the arc sine of 0.71697, and then hit enter, and that'll be 46 degrees. We'll round to the nearest whole degree. So if we know that is 46 degrees, well now we know this one because we add those two together. That is what added together is 81. So 180 minus 81, and that'll give us y. So 99 red balloons, 99 degrees. Okay, so now we've got the angle Z is 46 degrees. We got angle Y is 99 degrees. And now we can find Y because we needed that 99 degrees. So we can say the 12 over the sine of 35 degrees is equal to Y over the sine of 99 degrees. We needed the angle opposite the side they wanted us to find. So we actually had to do these first before we could do that. So they should have called that A, B, and that one C. Oh well, cross multiply and solve. So Y times the sine of 35 degrees is equal to 12 times the sine of 99 degrees. And then we divide by sine 35. And so that's Y. So when you click that in your calculator, again, make sure you put that n parenthesis, 12 sine 99 n parenthesis divided by sine 35. And then hit enter. And that should give you 20 point something, and we round it to 21 instead of whole numbers. So 21. All right. Lovely, lovely. Let's get 23. Last one on this page. And so they have a pretty picture for us. And that looks like this. We got 70 degrees here, 30 degrees there, 2.4 meters there, A, C, B. And they want us to find AC. I'm going to just call it X, so it just has a single letter. It's easier to think of as a single letter instead of two letters like AC. Okay, so X over the sine of 70. The side over the sine of the angle opposite is equal to the side over the sine of the angle opposite. And then cross multiply and solve. And so not even cross multiply and solve, just multiply both sides by sine 70 degrees. Remember that end parenthesis on the 70 degrees. We'll put a little times in there. Okay? So those cancel, and easy peasy. 2.4 times sine of 70, n paren, divided by sine of 30. That is 4.5. Oh, that's, is that kilometers? Okay, that wasn't just meters then, that was kilometers. And so, kilometers, I guess. Okie dokie. Lovely. All right, and then there's one more law of sines problem on the next page. And then there's 4 laws of cosines ones. So much time. Okay, we can do one more. 23. We did. Let's do 24. And so they gave us 40 degrees here, A, B, C, and they gave us 18 meters there. And now find AC. So again, I'm going to call that just a single letter. Here, you know what? We'll call it little baby b. Opposite. Big angle B is little baby b. That's the side. So they want us to find that side. So, well, they gave us, oh wait, they gave us one other piece of information, 12 on there. So what we have to do is we have to first find the angle, this angle, and then we could subtract from 180 and find that angle, and then we can find that side. So this is kind of a two-stager again. So we're going to say 12 over the sine of 40 is equal to 18 over the sine of angle C. And so then you cross multiply and solve. 12 sine C is equal to 18 sine 40. And we divide by 12 sine. Nope, just divide by 12. Sorry. Divide by 12. Divide by 12. And that'll give us a decimal. So the sine of C is equal to, remember to put the end parenthesis, 18 sine 40, end parenthesis, divided by 12, hit enter. You should get 0.96418. And now we do the arc sine of that. And that will give us 74 points, and we'll call it 75 degrees. So now if we know this is 75 degrees, well now we have that, and we can find that by doing 180 minus, oh wait, hold the phone, ambiguous case alert. It can't be 75 degrees, it's obtuse. It's more than 75. This is the ambiguous case. This is what I was telling you in the notes about the law of sines. Sometimes it can happen with just law of sines. Law of cosines is always locked in, but with the law of sines, this is an angle that's less than 90 degrees, but we're looking for the angle that's more than 90 degrees. So it is not 75 degrees, it is the supplement 180 minus 75 is 105 degrees. There are two triangles that can be created with side-side angle. And one of them has an obtuse angle and one of them has an acute angle. And we wanted the one with the obtuse because it's more than 90 degrees, so 105. Again, this will not happen on the test. It will happen. We do further expand on this in Techmath1, where we hit the ambiguous case. Okay, but that was the ambiguous case right there. We could have used the law of cosines to figure it, I guess. And then we could have avoided it, but oh well. So there's 105. So that's 105. So 40 and 105, that leaves 35 up on this one. And now we can use our law of sines where we say, okay, so B over the sine of 35 degrees is equal to 12 over the sine of 40. And then not cross multiply and solve, just multiply both sides by sine 35. Remember that in parentheses. Remember that in parentheses. Put it in your calculator. And so then we find B is, what does B turn out to be here? 10.707. And they want it to the nearest whole number. So B is 11. Okay. Whew. So that one was tricky. Okay. We'll do one last video on the law of cosines.